Okay, so hi everybody, my name is Jill Eisenstein, and tonight we're going to talk about wetlands. Wetlands, the word conjures up so many sensory experiences, places where you might need to wear rubber boots, quacking ducks, or is that spring breeding peepers, or wood frogs. The damp, cool feel of a swamp with dense tree canopy, shallow margins of a lake filled with sunning turtles, the pungent smell of a salt marsh. They have many names and many iterations: fens, sloughs, mires, moors, cars, glades, flats, swamps, marshes, bogs, bowers, and more. Note the subtitle of this presentation and listen carefully. See if you can hear why wetlands might be called nature's kidneys. I'll ask you about it later. Okay, it's not working. Okay, so here's the overview of the presentation. We're going to define a wetland, talk about its functions, talk about the wetlands in New York State, and possible management. So what is a wetland? How is a wetland different from other water bodies? Here are two good but slightly different definitions from accepted sources. Wetlands are lands transitional between terrestrial and aquatic systems, where the water table is usually at or near the surface, or the land is covered by shallow water. Wetlands are areas where water covers soil all or part of the time. Wetlands are important because they protect and improve water quality, provide fish and wildlife habitats, store floodwaters, and maintain surface water flow during dry periods. So what is a wetland? The dominant and dynamic presence of water is the defining characteristic of a wetland. The water is typically at or just below the surface, creating conditions that lead to the development of hydric soils, which means saturated soils, or hydrophytic or water-loving plants. Let's talk about the hydrologic regime first. Water in a wetland may come from many different sources, including salty ocean tides, groundwater seeps, a rainy climate, periodic river flooding, or pooled water resting on top of poorly drained soil. But water can change throughout the year and from year to year. So scientists look for signs that water was there at some recent time and for extended periods of time. How wet is a wetland? The natural hydrologic regime is the annual pattern in the timing of water fluctuations relative to a baseline. So when scientists look for a wetland and look at a wetland, they look at when does the water rise? How often? How long does that last? How much water does it get? How quickly does it happen? And that would be the hydrologic regime of the place. Hydric soils, saturated soils, they're saturated long enough during the growing season to create a low oxygen or anoxic anaerobic state in the soil. Water fills the pores, the spaces between the soil particles, where usually oxygen resides. So this lack of available oxygen limits the number of plant species that can live there. It changes the availability of nutrients and also slows down decomposition when plants die. Some wetland soils are dominated by organic material, which is, partially decomposed plants, and some, those are categorized as peat or mucks. And in those areas, decomposition is slower than accumulation, so the soil layers get thicker every year. Some are dominated by high mineral content. If the water has a faster current, for instance, the vegetation gets washed away. Indicators of hydric soils include leaves that have turned black from being in the water for a long time, or silt marks on tree trunks. There may be, as in this picture, mineral deposits along the root pathways in the soil, or the soil may be a grayish color. And those are both indicators of saturated soils and oxygen poor conditions. And the hydrophytic or water-loving plants. Vegetation is probably the most useful indicator that a wetland is present. Most plants take in oxygen through their root systems, but obviously hydrophytic plants can't do that. So these hydrophytes have adapted to survive with their roots growing in water for at least part of the growing season. Some of these plants, known as obligates, require water to survive or to outcompete other plants. Typical obligates include cattails, pond lilies, and skunk cabbage. To succeed in their waterlogged environment, wetland plants have developed adaptations. Morphological ones, such as long oxygen transporting tubes. Reeds, grasses, sedges have those. The ability to float on water, like the lilies we just saw, duckweed, some of the other plants. Buttress trunks that are usually thickened to the height of deepest water inundation. Lenticels, which are kind of like little holes in the trunk where they can breathe because the roots are underwater. Or adventitious roots that pick up oxygen from surface soil layers. They've also developed reproductive adaptations, specialized seeds and seed banks. The seeds may live for a long time underwater, and then they have cues for germination when drawdown occurs. Sometimes the seeds are floating. Some of these plants also have the ability to reproduce vegetatively from tiny fragments of stems and leaves. And also they have adaptations to frequent disturbances and sedimentation. I've seen trees in a swamp totally laying down in the water and branches sprouting from the trunks up above the water. So here you see one that's sprouting from a broken trunk, sometimes even from twigs. And some of these plants can survive sudden deep burial. It might be helpful to think of wetlands as transition zones between land and water, margins of freshwater lakes, tidal marshes, swamps along the banks of a river. One of the definitions we looked at earlier defined them as such, but by definition, transition zones blend into the bordering environments. This has made delineation of wetlands a problem. And it's been a costly struggle between conservation groups, scientists, government agencies, and many others with conflicting interests. So why are they arguing over it? Because we've finally figured out, after seeing so many loss of rivers, muddy rivers, flooding of lowlands, no recharge of hidden groundwater or reservoirs, animals dying off, we were like, oh, these must be important. They must be providing some ecosystem services, and they do. So they provide physical and hydrological ecosystem services, and here are some of them. They offer flood protection and stormwater control. So how they do that is wetlands intercept or absorb, and then absorb, store, and slow down the movement of rain and meltwater, minimizing flooding, stabilizing water flow through a watershed. Filling in wetlands often results in increased flooding, both downstream by speeding the water along, or upstream by breaking the water flow. When they slow down the water, they provide a sediment trap. By decreasing the velocity, which we just talked about, that same wetland vegetation that intercepts the fast-moving water intercepts sediment, and it helps filter it out. This reduces the turbidity, which you can see in this picture in the water, which is suspended particles in the water. They settle down in the wetland, and then they don't enter irrigation, navigational channels, lakes, and reservoirs. When I took a class with the Watershed Agricultural Council, I was fascinated to learn that turbidity is actually one of the biggest problems that they have in the watershed. in servicing the water for New York City water supply. And the reason is because the sediments act as a hiding place for bacteria when they treat it with UV. Also provides erosion control and coastal protection. Wetlands help prevent the erosion of shorelines and valuable agricultural land. They serve as buffers. Fun fact, studies have found that more than half of normal wave energy is dissipated within the first 3 meters of encountering marsh vegetation, such as cordgrass. Within 10 meters or 11 yards, the destructive energy is completely absorbed. So I have ground recharge, but it's groundwater recharge and surface supply. So because it stores water and collects it, a wetland will sometimes let the water seep out slowly and recharge the groundwater supplies. Sometimes they also recharge surface supplies of water. Atmospheric equilibrium is wetland plants produce oxygen, obviously, during photosynthesis. Since much wetland vegetation is made up of leafy perennials, photosynthesis occurs with constant, inexorable efficiency. Also, excess nitrogen, such as that contained in fertilizers, is broken down in wetlands through a process called denitrification. They also act as a sink for atmospheric levels of carbon and sulfur. And as an environment, a wetland is capable of reducing these elements to inert forms. They provide chemical ecosystem services as well. Pollution interception, which we talked about. But besides the things that we talked about, they also filter out pesticides, heavy metals, and other residues. How? They're buried along with sediments in layers of wetland soil. The anaerobic soil strata reduces them over time. Some of the plants in wetlands take up and filter some of the pollutants. Still others are processed by bacterial action. One pollutant, phosphorus, sometimes binds with iron or calcium compounds in the water in a process called co-precipitation, and then they're rendered harmless. They also process toxic residue. When heavy metal toxins such as selenium or lead wash into a wetland, they, like the pollutants, can be buried or neutralized in the soils, sometimes taken up by reeds or rushes and other plants and reduced through ion exchange. Now, that being said, some toxins can be made more potent in a wetland, and some overpower the capacity of the wetland. So although they can provide these services, there is a point where they just can't do any more. Waste treatment, wetlands can be remarkably effective in treating waste, both human and animal wastes. And this is due to their high rate of biological productivity, heavy deposition of sediment already talked about, and a high level of bacterial activity in the sediment layers breaks down and neutralizes waste. Wetland microbes can convert nitrogen into usable inorganic forms, and the plants can actually use it. So water leaving a wetland is frequently cleaner than water entering a wetland. Biological ecosystem services provided by wetlands include nutrient production and cycling. Wetlands are one of the most biologically diverse and ecologically productive systems on Earth. They convert sunlight and nutrients into food sources for animals. And some tidal wetlands exceed even tropical rainforests in energy conversion. The lion's share of productivity comes from dead and dying plants, detritus. This forms the base of wetland food webs. Larvae, protozoa, bacteria, and fungi live off the detritus and become the food of others further up the food web. Habitat. Many species of fish and wildlife depend on wetlands for critical parts of their life cycle. By providing breeding, nesting, spawning, resting, and feeding grounds, and cover, wetlands are recognized as one of the most valuable habitats for many types of wildlife. Young fish find food and shelter and protection in the vegetation. Over 2/3 of the fish, shellfish, and crustaceans harvested in New York, including both commercial and recreational harvest, are dependent on tidal wetlands for some portion of their life cycles. 1/2 of New York's protected native plants, many of which are endangered or threatened, are wetland species. Biological diversity, kind of already talked about. We as a society are becoming increasingly concerned about local, regional, and global diversity. Wetlands are important components of the landscape and contribute significantly to the state's overall biological diversity. They're habitat for many rare and indigenous species of plants and animals, and many in themselves represent unique natural communities. Finally, socioeconomic. Now, the first few things on this list I put here just because wetlands are important throughout the world. We're not going to focus on the first few because in New York State, they're not really used for this, but food, obviously, cranberry, bogs, rice, commercially important fish, birds, and animals in some places. Again, not really in New York, since we don't harvest beaver so much. Peat is huge in northern climates. In fact, the peat that has accumulated over centuries is being harvested faster than it's being replaced in many northern climates. Timber and fiber harvest, again, that's not something that takes place much in New York, but in many places they actually grow wetland trees for harvest. I think mangrove is one. But the last three are ones that we definitely can see in New York: recreation, open space, education, and research. Hiking, bird watching, hunting, fishing, trapping, boating, photography, painting, camping, some of the recreational uses provided by wetlands. Over 12 million New Yorkers annually participate in these outdoor activities. And long time ago, 1991, it was worth to the state more than $5 million. Obviously, that fluctuates, but that's a big deal to the state. Open space, interestingly enough, we've developed so many of our borders of waterways that wetlands in some places are the only green space left. They're the only parts that are undeveloped. Of course, we filled some of those in too to do developments. Education and research. Whoops. Sorry. Obviously, wetlands provide readily accessible outdoor biophysical laboratories, living classrooms, and vast training and education resources. The children in this picture are looking at aquatic macroinvertebrates, which are indicators of water quality. The types of wetlands in New York State, we have many different types of wetlands in New York. We have the salt water, the brackish water. We have wetlands along rivers, wetlands that flow, wetlands that border lakes. We have bogs, fens, marshes, swamps, bottomlands. And I have wet meadows on here, but wet meadows are actually a subset of marshes, as are vernal pools. Back in one of the earlier slides, I had a picture of a spotted salamander. Anyone who's ever helped with amphibians crossing the road know how important those vernal pools are to the amphibians. So those vernal pools as part of the marshes are just hugely important, and I'm going to talk a little bit more about that later. So bogs have no significant inflow or outflow. They have characteristic spongy peat deposits, thick sphagnum moss, They are very nutrient poor and often have insectivorous plants like sundews and pitcher plants, and they're pretty acidic. Fens, on the other hand, are wetlands that receive some drainage from mineral soil or rock, minerals in the rock. So even though they're peat forming, they often have grasses, reeds, sedges, wildflowers. Willow and birch trees are also common. They are oftentimes much more alkaline. Marshes can be freshwater or brackish or saltwater even, periodically saturated, flooded, or ponded. The vegetation is mostly emergent, herbaceous, and as I already said, there are many different types of those. In swamps, the wetland vegetation is mostly woody, lots of trees and shrubs, often with rivers, slow streams, or isolated depressions. Those are fed primarily by surface water. So what are the wetland trends in New York State? Well, let's see, total number of wetlands in New York State are about 75% of the wetlands in New York State are forested. About 14% are scrub shrub, and some are emergent cover type, not too much, and open water cover type are the fewest number of acres of wetlands in New York State. The wettest ecoregions are the Lake Plains, as you can see, where the soils don't allow the water to seep down, and the Adirondacks. Together, they account for 74% of the wetlands in New York State. The most common type of cover is obviously forest, and we're losing shrub, scrub, and emergent wetlands as cover types. Some people go, what? But I think it's mostly because it's just what forests do in New York. New York wants to be forest. So how are we protecting? This is a very interesting question. Because wetlands really have no market value in New York, it's been a problem, protection. But in New York State, we actually have lost over half of the original wetlands that we had. So we've drained them, we've dug ditches for agriculture, we've filled them for development, we've constructed roads, buildings, or both. But in 1975, the New York legislature passed the Freshwater Wetlands Act. And they had the intent to preserve, protect, and conserve freshwater wetlands and their benefits. Except in the Adirondack Park, where the Adirondack Park Agency administers the Freshwater Wetlands Act, they employ a lower threshold. Everywhere else, a wetland must be 12.4 acres or larger for protection under the Freshwater Wetlands Act. The categories they use to identify the wetlands are identified by the types of vegetation present. Smaller wetlands than 12.4 acres may be protected when the commissioner determines they have unusual local importance. And New York has a few other environmental conservation laws which are supposed to help protect wetlands as well. So they also protect 100 feet adjacent to the boundary of the wetland. DEC really tries hard to regulate activities. Some of the activities that they require a permit for are any kind of construction, any kind of alteration, filling, excavating, modifying, draining, except for agriculture, application of pesticides. So they have some good things that they're trying to do. Federal regulations. The Clean Water Act Section 404 in 1972 is the primary vehicle for federal regulation of some of the activities that occur in wetlands. But the true focus of that is on discharge of dredged or filled material into regulated waterways. A 1991 Government Accounting Office study concluded that Section 404 of the Clean Water Act covers only 20% of the activities that damage wetlands. Other programs, such as the Swamp Buster program, gives disincentives for conversion of wetlands to agriculture. In other words, they do monetary. They try to get agriculture to not fill in any of the wetlands, and they also have the Coastal Management and Coastal Barriers Resources Acts. In spite of all of this, permits are harder to obtain, but they can still be obtained. In a Supreme Court decision in 2001, all isolated wetlands, ones that aren't connected to other water bodies, lost all federal protection. As you can see, inland wetlands are more vulnerable than coastal wetlands to degradation or loss because current statutes and policies provide them less comprehensive protection. Vernal pools are perhaps the most vulnerable of all. So here's one of the reasons you may find wetland regulations confusing. Not only do states and local governments have their own regulations, but there are 5 different federal agencies that share the responsibility for protecting wetlands. The U.S. Corps of Engineers, Army Corps of Engineers is responsible for navigation and water supply. The EPA has authority over protecting wetlands from chemical, physical, and biological integrity. The Fish and Wildlife Service manages fish and wildlife game species, threatened and endangered species. National Oceanic and Atmospheric Administration is in charge of the nation's coastal resources. And the NRCS is focused on wetlands that are affected by agricultural activities. Thankfully, many states have adopted programs to protect wetlands, and New York has one of the most comprehensive ones. So, what about climate change? Can wetlands help with climate change resilience? Well, we know that climate change is going to and has already amplified conditions through many more frequent storms, increased wind and waves, more extreme fluctuations in lake levels and rivers, altered precipitation patterns and temperature regimes. So shoreline systems, being dynamic environments, they're subject to forces from both the land and the adjacent waters. And as we've talked about, functional wetlands provide a number of ecosystem services such as flood control, attenuation of sediments and nutrients, erosion prevention, improvement of water quality, and habitat. These all help with climate resilience. Restoring some of the wetlands can improve the services that coastal wetlands provide, as well as their resilience to changing conditions such as water level fluctuations, connectivity, nutrient and animal movement, and shoreline stabilization and erosion prevention. I'm going to talk a little bit more about the shoreline stabilization and erosion prevention in a moment. So here it is again. One of the things I did mention resilience to storm surge and sea level rise, but component of sewage treatment facilities is going to become even more important as we move forward, because the things that nature can do with sewage treatment, they have found far outweighs what human-built systems can do. And building biomass would be, if we add to the wetlands that we have, kind of get back some of the wetlands that we lost, the half that we lost in the state. We can maybe help build some of the biomass and get some of the ecosystem services back. So let's talk about the future of wetlands. Why do we need to talk about the future of wetlands? Because we've realized how incredibly valuable the ecosystem services are that they provide. Before we knew this, we destroyed so many of them. But now that we realize the functions and services they provide and that there's nothing else that can make up for them, it's kind of like the vital organs in our body. You can't take out a half of your heart and expect that your body's going to function the same. So I told you I was going to talk a little bit about heavily engineered human structures. And I'm going to talk about it when we talk about mitigation next. So if a permit does get obtained to destroy a wetland, and they do, with highways, dams, construction, mining, some places actually require a swap. So they require that there's a constructed wetland that offers the same amount of acreage and the same services. But constructed wetlands are also used, as you can see in this picture, for agricultural runoff. That's a hog farm, in case you can't read that. So it's used for agricultural runoff, municipal waste treatment, sometimes places with leaking septic systems, they'll put in a constructed wetland. So they're less expensive to build than human-made structures. They have low operating and maintenance expenses and can handle fluctuating water levels. We have built levees and heavily engineered stabilizing structures to replace the wetlands that we've taken away. But we've learned not only can they fail, but they also disrupt coastal processes that determine where coastal wetlands will form and persist. And we've created different problems. The barriers prevent aquatic species from accessing their breeding wetland habitats, and they prevent coastal wetlands from migrating with ocean and lake fluctuations. But constructed wetlands are one of the things that we do for mitigation. And here's what one looks like. Restoration. This is much more time consuming and much more holistic. It's one that's done well. And this one, by the way, this picture is they're trying to restore the mouth of the Connecticut River on Long Island. So it includes the reintroduction of animals, trying to get back to antecedent physical conditions, reconstruct the physical conditions, chemically adjusting the soil, biological manipulation, such as reintroducing the native flora that were there before, requires a lot of research and a lot of work, obviously, but to try to put back what we've destroyed. Acquisition, buy it. This action is perhaps the best way of ensuring wetland protection if it hasn't already been destroyed. When a wetland area is threatened by destruction from construction of buildings or roads or conversion to farmland, often acquisition is enduring protection. It leaves the wetland alone to do its thing without human interference. The Nature Conservancy, Ducks Unlimited, Friends of the Great Swamp, and others pursue this strategy. I think the federal government has also done some acquisition. I think the Great Swamp in New Jersey was a federally acquired wetland. Enhancement. This is when often it's just citizens try to help a wetland heighten, intensify, or improve specific purpose, such as water quality improvement or habitat. Sometimes it's called management, manipulation, or directed alteration. And protection and maintenance includes repairing water control structures or fences, or even replacing barrier islands. And under this would also come removing invasive species, which has become a bigger and bigger problem in recent years. So what can I do? Well, if you have a wetland on your property, you can make an easement or donate it to one of the organizations that can protect it. Please find and protect vernal pools. I have heard people say, I have this annoying water on my property every spring, and I just want to fill it in because it's messy and I don't like it. Please don't fill it in. Protect the vernal pools. We have species that absolutely need them in order to breed and raise their young. You can get involved with organizations like Adopt a Wetland or Wetland Watch or Partners for Wildlife, and all of those you can look up online. You can make or enlarge wetland buffer zones, and one of the ways that you can do that is trees for tribs and other things where you help plant things along the buffer zones. Invasives removal is huge. I know in our area, PRISM, the Partnership for Regional Invasive Species Management, welcomes volunteers. You can build birdhouses, nesting boxes, platforms. Here's a big one: exclude or limit domesticated animals. As you may or may not know, cats are a huge problem with birds. They are one of the biggest problems birds have. They kill them, but also livestock is big on destroying wetlands. So limiting or excluding them from the wetlands would be a good idea. And most of all, find a wetland to study. And this website will show you places where you could find one near you and you will fall in love. So now we're circling back to the opening slide, the first slide, and the subtitle was Nature's Kidneys. Can you tell me now why wetlands are sometimes referred to as nature's kidneys? So you can unmute yourself and answer, or if you want to type it in the chat box, that's fine.
This Dave Shepard, I'll start. Probably because they serve the same function that a kidney does. They filter. With all those small channels there, it takes all the particulate matter out of the water, so you get a clear water, sometimes even cleaner than what comes out of our wastewater plants.
True.
It can also act as, well, this isn't exactly a kidney function, but the wetland also acts as a surge tank, so you get an erosion prevention. But to answer your question, I think the main function of them is that filtration that it does and the chemical changes that go on. Now, with that, I'm out of my depth because I know there's a thing called a nitrogen cycle, but I have no idea how it works. I just know it does.
It does.
But the wetland is instrumental in that. It allows that balance to work. It allows the oxygen to come out from the photosynthesis that goes on there, and it's so you end up purifying, in effect, the water flow through any kind of downstream water course. So you're doing the same thing a kidney does. You're purifying the bloodstream.
Okay, there's another thing that if somebody else can chime in. There's another thing.
I'll read the chat box to you. And so far, and I think there are some others typing, but so far we have they clean impurities, they act as a filtration system, and cleans and filters the water.
Okay, so I don't want to spend tons more time on this, but also the cycling of nutrients is another way that the wetlands act as nature's kidneys. the nutrient processing functions. So obviously it is imperative to the ecological health of the earth. Can't live without such a vital organ. So now I have for you a video that was done in the Great Swamp, which is a place that I have volunteered. And I wanted to show it to you because it reiterates some of the points that we've made tonight in the presentation, but it also gives you a real feel for a wetland. Plus it's narrated by James Earl Jones, so.
Jill, the audio is not running currently. Do you want to pause it?
Let me, it worked earlier today.
Okay. I wonder if you go into advanced sharing options under share screen. And Steve Kinney, if you're still on, we had this issue with your birds call. So if you can remember how we worked around that, that might be helpful.
Yeah, I just remember it was under the advanced.
Under advanced screen sharing or something else. Let's see.
Yeah, it's under the share screen, and down in the left-hand corner it says share computer sound is a box to click. That's what we did before with the birds.
Okay, got it. Let's try that. Can you hear it now?
No, you're currently not sharing your screen.
We'll try one more time.
Okay. No worries. Your screen is still not shared.
Good now?
There you go, yeah.
Now, if we got the sound, we're good.
Yep, we're good to go.
Just 60 miles north of New York City, in the southern Harlem Valley, a little off the beaten path, running along the railroad bed, sliding under bridges, easing through town, and spreading out in a network of fens, rivers, and marshes, you'll find one of New York State's largest freshwater wetlands, the Great Swamp. The Great Swamp Wetland System was created 25,000 years ago, when the last glacial ice sheet scoured the Harlem Valley down to calcareous bedrock. The Great Swamp Wetland lies in a 62,000-acre watershed and runs for nearly 20 miles through 4 towns. The north flow follows the Swamp River through Paulding and Dover in Dutchess County, where it joins the 10-Mile River. The south flow begins in the village of Paulding and follows the East Branch Croton River through Patterson and southeast in Putnam County, where it empties into the East Branch Reservoir. Water-soluble marble bedrock underlies this massive wetland. The Great Swamp is a water-carved basin scooped out between the east and west ridges of the ancient Hudson Highlands. A reservoir, a great sponge, ebbing and flowing through drought and deluge, timelessly interacting with the floodplain that surrounds it. In the watershed, rain and snow fall on the forested uplands and run down to the wetland through tributaries, streams, and groundwater. When the runoff reaches the Great Swamp, it spreads out, settles, and slows. Sediments fall to the bottom, and wetland plants absorb pollutants. And still the water moves downward, filtered and purified as it flows, through thick glacial deposits, seeking the marble bedrock, recharging the aquifer and sending clean water into the Croton Reservoir system and to the millions of families who drink from it. Wetlands are among the most biologically productive ecosystems on Earth. Life is everywhere. 31 natural communities are found in the Great Swamp watershed. Forested uplands, emergent marsh, floodplain forest, wet meadows, and calcium-rich fens are just a few. The Great Swamp watershed is home to 160 species of birds, 36 species of reptiles and amphibians, 64 species of butterflies and moths, 37 species of fish, 58 species of dragonflies and damselflies, and 34 species of bees and wasps. Otter, beaver, mink, coyote, bobcat, and bear are among the many mammals found in the Great Swamp watershed. Wood ducks, black ducks, and mallards are just a few of the nearly 200 species of birds that use the wetland as a migratory flyway. All in all, the Great Swamp wetland system supports an astounding number of animals, plants, and natural communities. A significant number of them ranked as rare, threatened, or endangered in New York State. The Great Swamp wetland system, like any ecosystem, can be harmed by introduced environmental changes to which it cannot adapt. Many plants and animals in the Great Swamp are susceptible to small changes in water quantity, quality, and chemistry. Overloads of chemicals from human development, chlorides, phosphates, and nitrogen compounds, among others, can drain into the wetland from salted roads, septic fields, parking lots, golf courses, and wastewater systems. If the fragile ecosystem of the Great Swamp is thrown out of balance, habitats can be lost. Non-native species can invade. This in turn may degrade the Great Swamp's value as a clean water supply, fish and wildlife habitat, and recreational area. It seems not all municipalities and businesses and property owners are aware of how a healthy wetland ecosystem protects our water supply. Fortunately, there are a number of organizations, among them the Friends of the Great Swamp, or FROGS, working toward the conservation of natural resources throughout the Great Swamp watershed. A key community coalition, FROGS links many individuals and groups through information sharing and coordination, education and outreach, research and monitoring, and watershed protection planning. What can you do to help protect the Great Swamp? First, get to know the wetland and the watershed. Join Friends of the Great Swamp. Explore with us on hikes and paddles. Learn with us through studies and surveys. Advocate for the Great Swamp. Make sure your elected officials are aware of potential dangers to the Great Swamp, such as oversalting the roads, developing impermeable surfaces near the wetland, poor enforcement of protective ordinances, and malfunctioning sewage, wastewater, and stormwater systems. Educate people about the Great Swamp. Help us work to improve conservation, preservation, and educational and recreational access so more people can experience this remarkable wetland. And please, continue to spread the word about this essential natural resource in our own backyard, the Great Swamp.
Any questions?
Thank you so much, Jill. That was very nice. Well done. And the video was that was beautiful.
Finally got it.
Questions for Jill? You feel free to unmute if you have a question.
I have a couple of things I'd like to say.
Okay, go ahead, Andrew.
I thought the presentation was absolutely fantastic. It's really, really, really good. I would encourage everybody to support your local wetlands commissions, planning boards where they take wetlands under consideration. They are always in need of public support and public help, and that's really, really critical in order to save and preserve wetlands. One observation is that New York State does not protect vernal pools that are less than 12.5 acres. There is no protection for them at all. In some cases, they may be protected locally, but they are not protected by New York State, which is the only state in the Northeast that does not protect vernal pools.
Thank you for that, Andrew.
You're welcome.
I have Mike Newman says that he lives in West Monroe and has about 30 acres of wetlands, and Potter Creek runs through it. That sounds lovely. Wish I owned 30 acres of wetland.